anymore. So people let's say like, oh, let's catch this on film. That's a lie. There's no film. They'd say like, let's catch this on a memory bite or bit or something like that. So the Sonic advertisement. Now that your classmates have brought it up, if not now but after class or at some point, you check out the ad in the hallway that was actually distributed by the National Sonic like corporate headquarters, whatever. Sunday paper. My wife and I used to do a lot of couponing. So we get the Sunday paper. We like Sonic. We live close. I take the Sonic ad, cut it out, stick it on the fridge. A couple days later, my buddy and I are talking about going to Sonic. We realize this is a great deal. It's a wonderful deal. There's sandwiches from 99 cents, 99 cents, 99 cents. And then what we first thought was a bit more expensive, then realized was a bit less expensive, 1.50. But when whoever made the advertisement was formatting their values, they were using 0.99 cents to try to like attract you, as opposed to putting a dollar sign out here. Now, technically, that's wrong. If they do this, that's fine, right? Without the decimal point, that's fine. I forget if the 99 cents out there are correct, but then without changing their formatting, they went up to prices above $1 and still used the cent sign. So, myself and my genius, also interesting sense of humor friends, decided we would cut a penny in half. Illegal, don't do it. Destroying national currency is a no-no. But we figured penny, whatever. So, we take my buddy who's got construction tools, we cut a penny in half. We go to Sonic. We order the deal through like the little push button, whatever thing. We're like, yeah, we've got this ad here, and we'd like a couple of these chicken sandwiches for 1.5 cents. And they're like, excuse me? We're like, yes, your advertisement says that these sandwiches are 1.5 cents. We assumed we'd have to buy them in pairs to be able to pay you, but in case not, we brought half pennies along. And they're like, what? And I'm like, yeah, and I'm just like speaking as if this is just normal, right? Like, yeah, your advertisement says like we like some of these chicken sandwiches. And she's like, my manager's gonna come out and see you. Hang on just a minute. So he comes out, looks at the ad, and he's like, you know I can't honor this. Like, it's impossible. I'm like, you're right, but it's printed. And we ended up just paying like $1.50 for them or whatever. I didn't want to like ruin this guy's day. But he like wanted to keep the advertisement, and I was like, no, you can't keep this. I want it for my math classroom. And he said, well, I need to take it inside and make a copy of it. So he took it inside, made a copy of it, and apparently was like sending an angry email to somebody saying like, you know, what uneducated person is creating your advertisement?
We had somebody come in and do you have it? For 1.5 cents.
It's right on the other side of that wall. Sit down. Outside of class. Maybe you should observe the sweet bulletin boards that I've made out there. So, homework. We will get to a point that I stop saying anything about homework. We'll get to a point. I want to warn you. That doesn't mean you don't need to worry about it. It's posted in 2 places every day. You can take care of. We've been here for a couple months now. You know the process, right? Come in, plan book, write down your assignments. Then we get down to business. So, we today are going to be in 3.3.2, so let's date our notes. It is 10-4. What else does 10-4 mean?
It's 40.
No, 10-4.
No, 10 times 4.
10-4 means like Roger that, like I heard you, I got you. You never heard like 10-4, like if somebody says like...
Yes, my I don't live in the 80s.
That's like pop service. It's like radio communication. Yeah.
Today's my very last day of being 12.
Nice, enjoy it. Before you become the all-dreaded teenager. 3.3.2. And I'm going to label it Dec Div. Why did I label it Dec Div? Decimal division. Decimal division. This is no calculators. I mean, it's pretty obvious. I cut the symbol off, though, but 398 is going to be no calculators. As your teams, let's go ahead and dive into 98 and 99 if you can get to it. In 98, Mr. Garcia needs to cut short pieces out of a 16-foot 16-foot board to use as spacers in the wall of his new house. The pieces he needs for spacers must be 9 inches long. Without using your calculator, how would you determine how many such spacers could be cut from Mr. Garcia's board? Now, quick tangent because it's a pet peeve of mine. When you cut lumber, you have to account for the sawdust that you actually are each time taking up more than 9 inches. Here we are ignoring that. Let's assume we can cut with a laser and there's no sawdust. But in actual construction, you have to worry about the sawdust. Okay, like you. So say I have an 8-foot board and I want to cut 1-foot pieces. I cannot cut 8 1-foot pieces. The last one will be short because the sawdust lost. You can cut 7. The sawdust loss will be the width of the blade, which is normally about like a 16th or an 1/8 of an inch. Or probably a 16th. It's not very, I mean, the width of a blade is not very much. Probably about the width of the smart board. All right, try these 2 problems, 98.99. I'll give you like 5 minutes. I already read. Oh, well, that's some more strategy. We're just gonna use your mouth. Let's get a couple books open here, guys. There's 4 of us. Why are we only trying to get like? Where are you just like looking off there? He said what I wanted to hear. I love how you're like, he just walks away. Mental multiplication. Oh, I'm just bringing you back together for a second. You can ignore me if you want. But mental multiplication, because this is a no calculator problem, I went back to the back group, and Zen immediately started telling me that we needed to convert some units because we have feet and inches. Who else notified or noticed we have feet and inches, and that's a bad thing? We need to match units. Now, I've made a mistake up here. May, did you identify my mistake, or was that just because you realized we want to convert? When I set up a rectangle multiplication like this, I didn't know if you'd seen my mistake. I have a mistake up here. I'm going to try to mentally do my multiplication. She beat you to it just barely. Rachel?
You put a 1 instead of a 10.
Ah, this is 10 plus 6 and 10 plus 2. But now, if I want to mentally multiply these, 100, 20, 60, and 12, and I really quickly get to 192. Mental multiplication. And yeah, we wrote it down, so it's not quite mental. But break up the numbers, make them easy to work with, and put them all back together. So this, first thing you should realize, is 192 inches. I will shut up again. It's got butter coffee. Coffee. Dark roast with butter coffee. It actually smells. I think I almost spoke it yesterday. That's actually so do I. Should I just bring in like coffee scented candles or something? Especially as it becomes like fall, a little listen. What do you mean by round? 98, he wants to know how many spacers. Because in scrap lumber, like the leftover just gets tossed in the pile. I scooted it down a tiny bit. You know you have a textbook, right? If you do not yet have your textbook open, we're on page 167. Ava, how do we figure out a problem like this?
Well, you kind of have to draw that to like word it.
Yeah, that wasn't really solving, but that was like prep.
But then you have to divide the total number of like inches of the 16 on the board by the how many spacers you need to find.
So I think most of us figured this out, but again, mathematicians want to be efficient. Ava could have solved this by over and over subtraction, but she's smart. She realized we should divide. We have an entire length that we're going to cut into lengths. Now, here's an interesting thing. When we have 192 inches divided by 9 inches, I could also set it up vertically, 192 inches over 9 inches. What happens in a division problem when you have something on top of itself?
Then you need to either simplify it, then make it a decimal or whole number, or if it's like a greater number on top, then you need to make it a proper fraction by taking leftovers.
I agree, you're a bit too far for me though. I'm talking just about the unit right now. I'm going to come back to the number part. But our unit, inches divided by inches. What is our answer's label going to be? How many such spacers in your answer is going to be inches? When a unit divides by itself, poof, it's gone. So now our unit will turn into whatever the problem has given me, which is spacers. So when I do this division without a calculator, yeah, we can set up long division. But if we want to mentally make this easy, what number's close to 192 that would be a whole lot easier to divide by 9 with? Law? 180. Why? If I think about this as 180 and 12, right, that's 192. 180 divides super easy. It's 20. How many more spacers could we make with 12 more inches? One more. So we get 21 whole spacers. Now, I had this conversation with a couple groups. Was it only 21? No, what did we have left?
21.3 repeating.
No, we didn't.
No, we had 39.
We had 3/9. We had a third of a spacer left. Because remember, our unit is, so 0.3 repeating is correct. But the thing is, that's not inches. That's 0.3 repeating spacers. If you look at inches, you have 3 inches. But out of 12, that would actually be 0.25 of a foot. But if we're talking in spacers, then it would be 0.3 repeating. But do we care? No, that goes in my scrap pile. Toss it in the corner, and I'll use it for a project later, maybe. So let's look at 99. Check out 99. I'll give you guys a few minutes. Sloan. It's pronounced Sloan. I had a buddy in high school. It's Sloan. Sloan Taylor, really good football player. He was like starting quarterback. He went to Ottawa. Yeah, we were in high school together. And he went to St.
Was he good at math? And he's not a fractional revision.
They're just shoes. know, it's like wearing nothing almost, but it removes your soul. I have like soul, like soul.
Luckily, you were wearing those shoes the day I stole your
Wool, like smart wool socks, are some of the best socks. My feet will smell if I don't wear my proper stuff. So wool is really good because it wicks the sweat away from your feet. For a long time, humans have been wearing wool. Cotton, not as good actually. Yeah, wool is the best thing to wear for socks. Now, hold up. This is one of those situations. This is really dangerous. How Sloan wrote this. Why is this dangerous then?
Because she has two lines going the same way for the fraction.
So if I were to write this, and this kills me that they wrote it like that, I'd make my numerator big and my main bar big, and then a little bit smaller and a little bit smaller if we're going to have everything horizontal. Barely, like there's like a tiny font change, but I would make it really obvious, and the bar size too. This you could also go diagonal, like slightly. Now wait, they're talking about using a giant 1 here. So who can remind us what the idea of a giant 1 is? Will?
You multiply a number by the reciprocal.
Ah, so what you're saying is we multiply by the same thing on top and bottom, and that really does not cause a change, right? Okay, so here, Izzy, what giant 1 did they ask could make our fraction easier to deal with? 100 over 75, so I put 100 up here, 75 here. Ah, so this 16 I can really look at as a fraction, except that bar is going to be in my way, so we're just going to toss that over there. 16 ones. Then, and this is where we actually have a super giant 1. We know we want to make the denominator a 1. Sorry, brain overrided. I said 1 and I wrote 1. So if I do that on bottom, this denominator will turn into 1, which means numerator has to follow suit. 100 times 16, well, 1600. Wait. Isn't that essentially? But it's supposed to be the same thing, right? Because we didn't change anything. We didn't do anything. We slightly modified. We changed how it looks, but it's the same. All we did was move the decimal 2 places right, move the decimal 2 places right. We essentially multiplied by 100 on top and bottom. Right? So now I have 1600 divided by 75. And that's the same thing. Because this right here is just 100 times larger top and bottom. So it's the exact same thing. What do you think Sloan should what do you think Sloan should do? If you were now they set up a long division bar, right? I bet we can mentally process through this a bit easier. We have 1600 divided by 75.
Yes.
Think about how we can break up this number and work with my other number. I really do wish I do have candy that I'm giving away as prizes. I'll wager a piece of candy on who can give me the most efficient way to break this up to solve it. Is that a hand, Alex? Okay, what do you got?
By either using probably a long division.
I don't actually want to do long. So I'm looking to avoid long division. Like, in all honesty, I'm bad at long division. I avoid it any chance I can. So I have developed other strategies to avoid what I know I'm not good at, which is kind of good and bad. I could have just gotten better at the thing I'm not good at. But I've developed a way around that. Now I have too many things. Bouvendeer's card was actually up and I skipped it because I'd already talked to him. So let's go to Bouvendeer.
So you can split 100, not like split it, but you can make 1,600 and 160 times 10. What do you call it?
No, that's not here. What will make it the easiest? Well,
I was thinking maybe just to do short division. Short division.
I want to make this an addition.
Oh.
Ooh. Naya? Ooh, no, not the easiest. Zen?
Oh, wouldn't you want to make it 150 plus 10 because 75 would go into 100? What? I'm so close. No! So close. No! I said it wrong. 1,500.
1,500! Not 150. So close it hurts. Why? Why 1,500? Do you know, Alex?
Yeah, because the six is in the hundreds place. So, well, if it had to be the same, then it would have to be this, like, also.
Yeah, explaining it's a little hard. Think about what we can do easily. I can think about doubling a number real easy. Every two 75s is a 150. So how many 75s does it take to make 1,500? Not 10, 20, 10 pairs. So this I can make become 20, and because I didn't deal with all of it, I still have to do this part. Can I fit another 75 in there? Yeah, so another whole, and then what's my leftover? I got 25 out of 75, which will end up being a third. So we get in total 21, and if we reduce, 1/3. So think about the ways and that's not part of the lesson, but one of my big goals is how you start to visualize and work with numbers just to make things easier. Okay, I don't really care. I mean, I do. I'm supposed to, and because this was recorded, I should say I care how you do on this test at the end of the year, but that's not really my focus. My focus is making sure that you're set up for success in your future math classes and to be math literate to have success in life. Like financing a car, buying a house, taking a loan from a bank, all these things, you want to have good number sense. Moving on. Yeah, wherever I put that. This. Yeah, don't. Don't be one of those 8 out of 5 people. Many people have difficulty locating the decimal point in the answer to a problem like that. I don't remember which one is which. If I wanted to take that and go back to a stacked vertical division representation, would the 16 be on top or on bottom? How do you know? I just have to give you guys like as many ways as possible. Numerator, right? It's inside. The inside number is numerator. Numerator goes inside. That's how I do it in my brain.
I think of it as like the first one. I call that thing the house. Let's say the first one is into the house.
Okay. So either way, if we write this stacked, we're going to get 16 over a half. How could I rewrite this? Talk with your team to use whole numbers. If you get done with that, move on to 101. I'll give you a few minutes. Talk with your team. Nope. By the way. We're finally doing the project and stuff. Do you know how long we spent on Khan Academy this summer, all photo left together? Do you want me to tell you? Or do you want me to perform? Well, take a guess. I'm curious. How many hours did you spend on that? You want me to tell you? 51. Fragments of time. They piece in together, right? 10 minutes here, 20 minutes there. All together. 51 hours. No, it's nice. This is why you're so like confident in your skills and like all your work and everything. You're killing it because you just spent right all the time.
That's why you don't get
So, do you want somebody to like do homework with? She's the girl right there.
Don't choose me because I'm gonna get zeros.
How we doing?
150 and
100. Move on to 101. Hey guys, once we get done with the problem, move on. In total, all fragments of time put together. Over the summer. Well, over the summer and whatever she's done up to now. I didn't actually have to stop. Nina, she was like the mega winner of the Summer Smarties thing. I've got you. Like, you'll get projects from Friday. At least 8. Anyone who did work on the Summer Smarties content. Alright! It's really easy to wait in. It's not like do quizzes or something. What? No, you don't need it. It's just to like do work. You made like 80% of the way through everything. Miss Dunn! Tell me what your group decided to do to get 16 divided by a half into whole number values. You did not? So wait, they have an answer, yet you were complaining. 10? Where's a 10? Or a 5? We're doing 100, right? Nope. Will? Yeah.
Because 0.5 is half of like one whole number, so that would mean that if you multiply by 2, because 0.5 times 0.5 is one whole.
Now, I do have to say, but you're right. Moving here, you were not wrong. I could here. I wanted to be mean to you because you guys were goofing off. We could do 10 over 10. Right? Because we see this needs to move a tenths place. And then that would be 160 over 5. But that's bigger than what I would need to deal with. What Will is saying, now, this is easier. Because what Will is saying, I just have to say it loud. Make sure it's on the film. Which is not filmed. Which you said out loud like a long time ago when we first started this problem. But what Will decided to do was take the portion and make it a 1, which means there's no work left to do. If you multiplied by anything other than 2, you did too much work. Not that you were wrong, but you did too much work.
No one was stupid. And they said I was because they said I was goofy. I figured a way out of this. Only by my kid. And then he said no. I didn't actually kind of.
So you may now, if you want, use a calculator, or I challenge you to not.
Nope. Alright, let's do it.
So hold up, let's do one of these together. Hold on. Let's do another one of these together because I want to see if we've got this kind of idea. Right? If we look at B, we say 1.5 divided by 0.25. What's the absolute easiest way to figure out what this is simplified? Okay? Times a giant fat one here, of 4 over 4. That turns my denominator into 1. My numerator becomes 6. And your answer is just 6. So back in the day, if somebody handed you what's 1.5 divided by 0.25, you're like, but a calculator, please? This is easier! It's literally faster than typing it. So, continue. Have fun. If you had 3 quarters, how much money would you have? Hey, the just making noises? Not cool. That's what we were saying. We want 2 of them. We want to give you 3 pennies. Yeah, I only skipped A because it's not. It doesn't have a portion on the bottom. Right? It has a whole number on the bottom already. No, I mean, you could put 3 over 4 equals 1, whatever. It doesn't say show your work, it says show an equation. Alright, a lot of us are making A more complicated than it needs to be. When it says show an equation, all it means is show what you figured out. 3 divided by 4 is 0.75. That's good enough. If you know it. What? Now, I'm going to try these without calculators. What else could I write to represent C but use whole numbers? That would be the same fraction. Zen? 30 over 5. Boom. 30 over 5. Double the top, double the bottom, because doubling the bottom makes it a whole number. Then this just becomes 6. My next one...
What you do is you just take the 1.5 and 0.25 and move the decimal up 1 for both, and you get that fraction right there.
What are you talking about?
I just thought of it the same way. I saw the connection that the 1.5 divided by
I see.
0.25 is just 1 decimal to the right over from 15 divided by 2. So
That's what Zen is saying, is it's the same problem, essentially. 30 divided by 40. Doesn't work if we all talk together, so please try to sit in your conversations while we go over answers. Zach, what'd you notice about, whatever, D, 30 divided by 40? Yeah. The top and bottom can both be divided by 10, which becomes 3 over 4, same as A. Now, in E, Oliver, we have 0.003, so 3 thousandths, over 0.004, 4 thousandths. How could we solve this?
You just multiply it by 100.
Okay, multiply by 100. I get...
That would be better.
If we multiply by a still 1, but here My 1's going to be really fat. We can multiply by 1,000 over 1,000, or mentally just realize if these guys are in the same decimal place, this is really the same as 3/4.
Take out the confusing numbers, do it, and then put back in the same thing.
So 0.15 divided by 0.025.
No, they're not in the exact same spot. They're in the same spot. The first one is there.
Now hold up. Hold up. This is interesting. Zin said they're in the same. Well, they're not the same, but they're kind of the same. Like, how? Hold on. I like what you said. I like that dichotomy. How many decimal places? How many decimal places? What if I do that?
Ooh.
Right? Because then
That's such a magical thing.
I would like record that as like my text tone. Like, oh, huh? It works. So now hold up. What could I make this equivalent to? 150, not 250, over 25, which is super easy. This really hard, really. I get scared. I'm not joking. When I see things like this, it's scary. This is really easy. Hey, so what are we really getting at here? Like if we go, I'm gonna skip G. If we look at H, so I'm gonna pull H down here. If we look at 0.0015 divided by 0.00025, who could talk me through the easiest way to deal with this problem? Maya?
You can add a 0 to the 0 plus 0.
Okay, why?
Make them like even so that.
Hey, Booger, stop talking over people. This is like a problem that you have, and I'm just going to publicly address it so we all agree that, yes, let's try to get you to stop talking over people. We can. I'm far away. We can hear you. So we get the same decimal places. Then what we would actually do, but once we get good at this, we can just like skip this step and just do it mentally. Giant 1, right? Whatever your giant 1 is, it essentially says what I do on top, I do on bottom. We can think about multiplication, or you can think about physically moving, right? If I think about physically moving, I can move this decimal place. How many places? Yeah, the bottom makes me move 5 places. So the top, I have to do the same, and we get 150 over 25. Same thing we've had. Except what looks really ugly to start is actually really easy to deal with. Will?
I just wanted to say that this problem, in my mind, once you add the 0, just take out the unnecessary zeros that you don't need.
Yeah, like, and the decimal and everything, like, yeah.
Take all that out, because that's confusing. So just be like, take out the confusing numbers, and then if you want to get the answer, there's the confusing numbers.
As long as you understand
As long
why.
as you put them back in.
Well, as long as you get why you're doing it, like what the rule is. Sweet! Let's charge forward. Or maybe that might have been it. Is that it? That can't be it.
Is it? So dash.
No, I don't think that's it. I think that's all that I copied. Here we go. 102. Now hold up. So we can quickly run through these. Actually, I'm just going to move this down. So Eloise, love that name. Eloise sees 7/100 divided by 4/10. She's like, well, I just really can make this 7 over 4. Can't she?
No, they're not in the same direction.
So set this up for her. Write in your notes. Write her 7/100 over 4/10. What would Eloise need to do? Who could coach her through it? Bilal?
Okay, I think you would add a 0 to the 4/10 so that they're in the same amount.
Yeah, same decimal places.
And then, just,
What would we multiply to get the decimal to the right of our 7?
oh, 100.
100. So what we think is we have a giant 1. We're multiplying by 100 up here. Multiply by 100 down here. We get 7 over 4D. Not 4. Or 4T, to say it correctly. Not 50. 50. 50 cents, Mr. I forget what his actual name is. But yeah, 7/40ths. Then we can deal with that. Right? So 7/40ths. We could actually do a couple other things with this. Is there a way to get 40 to 100? If I'm still trying to mentally reason through this whole thing, is there a way to turn 40? I shouldn't. What's 40 times 2? 40 times 3? What will get me to 100? 2.5. What's 7 times 2? What's another half of 7? 3.5. So if we want a decimal, this turns into 0.175 because this, remember, would be percent. It puts the decimal 2 places over, so we would get 0.175 actually here. Because this, I could actually rewrite as 175 over 1,000, and it's 175 thousandths. Right, if this doesn't make sense, jumping from here to there, move the decimal to the right, move the decimal to the right. You can do anything you want as long as you make the actions match. Top, bottom, left side, right side. It's all about keeping things balanced. Will? All right, let me know if it comes back. Practice this with ABC. Turn it into so that every number is an integer, an entire value, no partials. And I can't say whole number because it's negative, but we're essentially making whole numbers. Just negatives are not whole, they're integers. Me? About 84 of them every year. They show up new. I have to learn their names, and I have 4 fur babies, so my kids. No. I don't know where my wedding ring is right now. That's concerning me. I had it last night, and I was working on a couple projects and doing laundry. But yes, I normally have my wedding ring on, but I have been married for 5 years. My wife and I have been together for a long time. No. Yeah, for the record, I have no relationship to Nikki Hudson. Yeah, I know. Or somebody running for school board. She's got signs all over the district, so now my last name is on signs and people know. But no relation to me. We're running out of time. Alex, how many decimal places do I need to move in A? Hey, turn it down just a little bit. You can keep talking, just turn it down a time. That'll work for numerator and denominator? Twice because the denominator, so if I move it twice up here, I have to actually add a 0 on. I get 250 over 25. And B, Rachel, how many decimal places do I need to move in our fraction? 2, because the 0.12 on top, or the 1.12, so I add a 0 on bottom, negative 112 over 70. And C, Mina, how many decimal places do I need to move in that fraction? Come on, Green.
10. Okay, 1.
Yeah, 1 decimal place, 1 decimal place. We can just move a single decimal place, top and bottom. 591 divided by 3.
Can I answer that?
Sure. We would want to check it. But yeah, with that, I believe we understand the conceptual of what we're doing today. Please work on your homework. Let me know if there are any questions. I believe there's one more section. Tomorrow's only Thursday. Yeah, we already did a little bit. We were in the CCA section. You're close. All right, have a great day, guys. You got to get out of here to your next class.